Yes, this is the video for section 3.9 related rates. And in this section, this is our learning objective. There's only one rates of change of one quantity in terms of rates of change of another quantity, now which may be easily measured. Okay, that is, we'll be at the end, should be able to find the rates of change of quantities with respect to time in this section. So in 3.9, we're going to look at the quantities that are given. We're going to be changing with respect to what? To time. Okay. Now, if we are for example, if we are pumping air into a balloon, both the volume and the radius, okay, could see that of the radius of the balloon are increasing, and their rates of increase are related to each other. So, but it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. Okay. So in a related rates problem, the idea is to compute the rate of a change of one quantity in terms of the rate of change of another quantity. Okay. The procedure is to find an equation that relates the quantities involved. In this case, the volume and then what? And the radius, and then use the chain rule to differentiate both sides with respect to what? With respect to time. So in other words, the quantities involved depend on what? A third variable, which is time. Okay. So here is an example. Or first, look at the problem, the strategies that we go through. About 7 steps. Okay. Yeah, read the problem carefully, and you want to understand what is given in the problem, the information given or known, and that is what is not or known. And then, if possible, you draw a diagram, and then you introduce what? Some notations. All right. And in this case, we assign quantities, okay, that are functions of time. Okay, the quantities that are functions of time. So in the previous example, in this case, we'll be finding what? The volume and then the radius, and expressed in terms of what? Time. Okay. Now, after we write the equation, then we want to differentiate, okay, express that quantity as a rate, okay, in terms of a derivative. So once we have an equation, then you can what? Differentiate that. Okay, so write an equation that relates all quantities involved. If necessary, use geometry of the situation to eliminate one of the variables by substitution. So if you have you have to get maybe 2 or 3 variables. If all of them depend on what time, then it is possible to that. If not, then sometimes we can eliminate some things. Of course, we use a chain rule. Again, you see how powerful that is. And then we solve for the unknown. Okay. So in this example, exercise number 1, it says if V is the volume of a cube with edge length x, and the cube expands as time passes. Okay, find the V, the t, in terms of what? The x, the t. Okay, so if we go by the strategies we have there, okay, step 1 is that what do we know? We know that what the quantities involved are what? The volume. Okay, so we know the volume. In this case, we're going to let be is in the questions what, and then we also know the size of the cube. Okay, and the size of the cube is what? X. This is a cube, right? It is not a square. It is not. That's a cube, and its cube has a square base. All right. So that is the step 1, and then step 2. Okay. Step 2, we can draw a cube, right? So this is how my teacher taught me a long time ago. So I'm going to draw a square for each 2 squares. Okay, and then let me erase that. That's not a very good one. Okay, so here's my square. So I'm going to draw a square. like that. See, I'm drawing that. That's my cube. Okay. Right. So it has the size is what? This is x. That is x, and then the height is also what? Is also x. That's what a cube is. So that's the diagram. And then step 3, it says that introduce word rotation. Well, we know that in rotation assigns symbols to all the quantities that are functions of time. Okay. Now, according to this, we have what? We said we are given this dv dt, and then what? Dx dt. Okay, because the quantities are what? The volume, and then what? And then the size of the what? Of the cube. Okay, this is given, but in the question, we have to be able to find that. Then step 4 is that it says that express the given information in the required what rate in terms of what? Derivatives. Okay, now step 3, we need to find this is step 4. This is step 4. And then step 3 is that this is a volume. And then what is the volume of a cube? This is given by what? X what? X cube. So V and X depend on what? Depending on time. All right. Then step 5 says that write an equation that relates all quantities involved. If necessary, use geometry and eliminate the other. Okay. So now, when we have this, okay, we don't have any. This is just two steps. So I would just say this is also step 5. Okay, if you want to call that, that's also step 5. Then steps 6, we use the rate of chain rule to differentiate this. So we're going to differentiate this with respect to time. So then dv dt is equal to what? 3x dx what? dt. Okay. Now it's just solve for the unknown. Now this question doesn't give us any value of x, doesn't give anything else. So this is your what? Your final answer. That is what? dv dt equal to what? 3x. If the question went further and said that find the what? The rate at which the volume is increasing, okay, is increasing when x is say 2 centimeters or 2 meters, and then the rate at the SDT is also given. Okay, when those are given, then we can find what? We can find the VDT. So this question, that's all we need to do. Okay, in the next question, we're going to more detailed where not a lot is given. This is the first one, was an easy. Okay. So the next one is that this is the exercise number 3. And then it says that each side of a square is what? Is increasing. Each side of a square is increasing at a rate of what? 6 centimeters per second. At what rate is the area of the square increasing when the square, okay, the area of the square is what? 16 centimeter square. Okay, this is area. So type it there. When the area of the square is what? 16 centimeter square. Okay, so if I go back and look at this question, and what is given? So let's go by the steps that we have. Okay, I'm going to take my time and go through all the steps. So step 1, it says that, what does step 1 say? It says read the question word carefully, and we want to understand this. When we do know that the square is increasing, okay? Square is what? Increasing. Okay, and then the side of the sides, if it's increasing, it's because of the sides is also what? It's increasing. Okay, the size is increasing, all right? And then if we go back and look at it, it involves what? we are talking about certain quantities. Okay, what are the quantities involved here? We have what? Area. Okay, and then the size, of course. Okay. Now, step 2, it's a square, so we can draw a square. Okay. Now, if we let the area be what? A, okay, and we let what? The size be what? X. So if you do know this is X, that's a square, and then the area is what? A. So we're going to say that A is what? The area, and then X is what? The side of what? And both of these quantities depend on what? Depend on time. Now, even if we didn't give anything, and look at this rate, okay? Centimeter per what? Per second. All right. Then step 3, express the given information and the required rate in terms of what? Derivative. So introduce what? Notations. Okay. So as we can see, what's the information known? What is given? Okay. So step 3, what is our given? What's the given information here? We know the what? The rate, okay? The side of the square is increasing, okay? So if the side is x, we know that dx dt is giving us what? 6 what? Centimeters per second. And then we also know that the area is what? 16 centimeter what? Square. That is right here, okay? Now, what is unknown? What is unknown is that, what are we looking for? What do we want to find? It says, well, we should find a rate, okay? At what rate is the area of the square increasing? So we want to find what? dA, dt, this is unknown, okay? This is unknown, okay? So we want to find this when the what? dx dt is that, and then the area is what? 16 centimeters square. Okay, then step 4 says express the given information in the required rate in terms of what? Derivatives. Okay, so we combine the what? Both 3 and then 4. Step 3 and 4 together. Now let's go to step 5. It says write an equation that relates all quantities involved. All right. Now we want to write an equation involving what? The A, the x, the x dt, and the a dt. Now, if it's a square, what's the area? Formula for finding what? Area. Okay. Area of a square is what? A is equal to what? Just x squared. So then that's the quantity. The two quantities, the area and then the size of what? Of the square. Then step 6, it says that use chain rule to differentiate. Okay, use chain rule to differentiate. So we differentiate that. We have for dA with respect to time is equal to 2x dx what? dt. Okay, so remember we are looking for what? The question is that what is what? dA, okay, when a is what? 16, okay, 16 centimeter what? Squared, and the x dt is equal to what? 6 centimeters per second. So the question is, what is x? Okay, so if it is x, because before you can find the ADT, okay, we must know x, because look at it, what's the value of x? That's why they gave us the area. Now we know that a is equal to what? X squared. So if a is 16 is equal to x squared, that means that my x is equal to the square root of 416, and that is what? 4 centimeters. So therefore, the dA dt is equal to 2 times 4, and then times what? Times 6. Okay, so that will give us what? 48 centimeter what? Square per watt square, because it is what? The area, that's a unit, centimeter square per watt per second. And that will be your what? Your answer. Okay, that will be our answer. All right, the next example is, we'll do more examples in class, but I want to go over one example from the book, okay? And then I won't go through the steps, but I'm going to embed all of them, because some of us sometimes say, okay, how do I don't need to write all the steps, but that's fine. Okay, now here's an example in the book. As usually, I don't do that, but let's take this one. It said air is being pumped into a spherical balloon, okay, so that its volume increases at a rate of 100 centimeter cube per second. How fast is the radius of the balloon increasing when the diameter is what? 50 centimeters. Okay, now let's read the question and make sure we understand. See, the air is pumped into, so we have the shape, the geometry is what? It's a sphere. Okay, we're dealing with what? A sphere. All right, so if I want to draw a diagram, that would be, say, my what? My sphere. Okay, and this is my diameter. That's my sphere. And the diameter is what? Is giving us what? 50 centimeters. I can call that X. All right. Diameter, or let's can call it what? D, whatever. We can say this is a D. So that's my sphere, and then the radius. So we have the sphere, and it said we're also dealing with what? The volume. Okay. So this is how we try to understand. Now, how fast, please, how fast is not the same as how long. Now, how long is what? That is find the time. But how fast is what? The rate. Okay, how far is what? Rate. How fast is what? Rate. You are looking for what? How fast is what? Is rate. So let's try to identify two things here. They're giving information that the rate of increase of the volume of the air is given. It's 100 centimeter cube per second. And the unknown, okay, what they're looking for, that is be the dV/dt. And the rate of increase of the radius when the diameter is what? 5 seconds. Sorry, 50 centimeters. Now, let us say, in order to express these quantities mathematically, we introduce some suggestive notations, okay? We have to, the V represent the volume, and then R represent what? The radius, okay? The key thing is to remember that the rates of change are what? They are what? Derivatives. So when you say how fast, we're dealing with derivatives. In this problem, the volume and the radius are both what? Functions of time, okay? And the rate of increase of the volume, we'll write it as what? dV/dt, and the rate of increase of the radius is what? dr/dt. Okay, so then let us go further. What is given in the question, we know that it said that the rate at which the volume is what? Increasing is what? The increasing is what? Positive. If it says something is, maybe if the air is being deflated, then the volume will be decreasing as well as the radius. So in that case, in this case, this will be what? Negative, not positive. So if it's increasing, it's positive. If decreasing is what? Is negative. So what is given from the question is, we know this, and then we know dr/dt, okay? That's unknown. That's what we are looking for when the radius is what? 25, because radius is equal to what? The diameter divided by 2. So that's why I have 50 centimeters over 2 is the what? It's 25 centimeters. That's how we got that from. So we need to find a volume, equation that connects what? dV/dt and dr/dt. Because if I don't have that connection, I cannot find what dr/dt, which is the unknown. All right. Now we know that the formula, okay, formula for finding the what is the volume of a sphere is given by of V is equal to 4/3 pi r cube. Pi r cube. Okay. So the question is that we take this and differentiate it with respect to what? With respect to t, okay, using the chain rule. Okay. So if I differentiate that, I find dv dt will be what? 4/3 pi, because pi is a constant, then times 3, because the radius will be r squared dr what? dt. Now when you simplify that, this will give me what? 4 pi r squared dr what? dt. And that is, this is equal to dv dt. Now notice that this is, that's what connects what? Both what? dv dt and the r dt. Now I have it in the next slide anyway. So that is, this is using the chain rule. That's what we got. I just showed it to you. So now the question is that we need to solve for what? If you have dv dt, we need dr dt. Okay, so when you divide both sides of the equation, so let's go back here. If I divide this by what? 4 pi r squared, and this side also by what? 4 pi r squared. Then my dr dt is given by this expression here. So now we know dv dt, we know dr, we know the radius. We need to substitute this and then solve for what? Okay. So if you have dv dt is what? 100, and then 1/4 pi 25 squared divided by 1. You simplify everything, you get this. All right. So the radius of the balloon is what? Increasing at a rate of that, which is approximately this. Okay. So that is it for this video. We'll do more examples in class, and I'll see you very soon. Thank you.